All right, we're going to go do the control example. I'm connecting to the remote network, except it's not behaving right now. See if there's a reason for that. Nope, we still have live internet. There we go. So we will load it up. Open Epanet. If you're doing it on your home computer, you won't have to necessarily do all this wind steps. Open. And we want to go to Control 1 example. And here is the network. The key features are this tank. And I'm going to go on to the handwritten notes, which you can download later. And we will put in the features of the tank. So the tank has a bottom elevation of 850. Maximum level 150 max, and then the minimum level is 100. So let me redraw. So there's a rough approximation of what our tank looks like. And essentially we have a total usable depth of 50 feet. And let's see, diameter is 50.5. I wonder why he picked 50.5. 50.5 feet, and it's a cylinder. So when the water's down here, the tank is empty. This part of it isn't part of it. And when the water is all the way up here, the tank is full. So if we have an independent source of water, we have a pump over here somewhere, we would like it to detect when the tank is almost empty, turn the pump on to refill the tank. And when the tank gets close to full, we want to turn the pump off so we don't overfill the tank. That's basically our control question. So returning back to our program input, let's examine the pump. So the pump has pump ID 9 and it has a pump curve associated with it. The tank has tank ID 2. Let's write those down. So the ID of the tank is 2. The ID of the pump is 9. You'll see in a moment why I wrote those down. Next, let's check option times. The model is indeed set up to run over a 24-hour period on 1-hour time steps. And just above options is controls. There's 2 categories of control. There's simple and rule-based. In this particular example, I think simple is the only one that's active. And there's the control rule. Now let's see what it says. It says link 9, which is the pump, open, which means on, if the tank water level is less than 110. And the link is closed, which equals off, if the tank bigger than 140.
I did get 30. Is this 30? 50.
50. So on the next page, we're going to draw a better picture of our tank.
Yeah.
Okay, so the base elevation was 850 feet. At 100 more feet, so 950. Our tank starts. We're told the tank is 50.5 feet in diameter. Let me get back to my previous page. 50 feet tall, so it goes up 150. So there's our tank wall dimensions. This total height is 50 feet. In terms of the way the control rules are, it's measuring from this base height. So we're setting, we have 110 feet from this base height and 140 feet from the base height. So this is when we turn the pump on. Here's when we turn it off. The goal being we're trying to keep the water between here and here.
Two levels, yeah.
Make sense?
Yeah.
I mean, whether those numbers themselves make sense, but the idea is makes sense. We want to keep the tank elevation in here. Now, in terms of heads, see, that's going to be 950. This is going to be 960 feet ahead at that point, and that one's going to be 9. It's 10. It's 40. So this should be 990. I think I got these right. This is a nuance of EPA-Net is keeping tracks of head is this column. This is water surface above the bottom, that column. This is depth above tank minimum. All the same thing, but they're just referenced to different datum. Okay, let's go ahead and run the simulation. So to run, it's all set up, so there was no data input on our part. Run the thing. It says everything's happy. Let's look at how the pump behaves, then we'll go look at the tank. So if we look at the pump, let's look at flow rate. So it looks like the pump was turned on from hour 0 to hour 13, and then it got shut off. And then at hour 23, it got turned back on. So that's what this is showing us. Let's examine the tank. And we'll plot the head. So the tank started out at whatever its initial depth was. It was almost filled up to around 990. Then the pump is turned off, and the tank drains and supplies until it gets down to 960. Then the pump turns back on, and it repeats. And if we want to see more than just a few, more than just one day, we can change the time. Go to 4 days, so that's 96 hours. Hopefully the tank doesn't run dry. Oh, good. I'm glad that worked. Now going back to our picture, the tank total head should be between 950 and 1,000, and our target's between 990 and 960. And sure enough, we're filling, draining, fill, drain, fill, drain, fill, drain.
Sort of.
Now let's see what happens when we change our control rule. Let's, instead of turning the pump off at 990, let's turn it off at 980. So how would we do that? We would go back to our control rule and simply edit the rule. We want to turn the pump off at a depth of 130, which would come out to be 980. So now that wiggly line should go between 980 and 960. Hopefully I got it updated. And let's see what's going to happen is the pump, I think, is going to have to spend more time on. Let's see if I can get both plots up. I haven't rerun it yet. There, that should give me what I need. And then I want to look at the pump. Okay, before I rerun it, do you understand these two plots? The top plot is the pump on and off, and by design it's almost a square wave. That's because the pump curve is an on-off pump curve. And the bottom is the water in the tank. So we just changed it so that this upper number should go not to 990 but to 980. The lower number we left alone. Because we have less storage in the tank, we expect the pump's going to have to be on longer.
Yeah.
But we won't know until we run the simulation. So there's the simulation, and notice how the pump is spending more time being turned on. And our tank looks horrible at this point. And if we even go so far as to modify the control even further, I don't know why we do it, but let's say we want to keep everything in a 10-foot zone. So between 120 and 130. Now when we run the simulation, the tank is going to be draining and filling a lot faster. There's going to be even more time that the pump will have to be turned on.
It means in that upper one, the stay time is more. I mean,
It has to be.
Yeah.
We have less storage.
Yeah, but in this particular case, it's switching fast. A little, like the peak. If you see the peak, one is a little bit nearly square waves, and in other cases, it is just like continuous.
And if we increase our storage capacity, see, looks like the lowest we can go 105. I'm not sure the system can respond, but what I'm going to do, we're going to let it go as low as 101, and we'll let it get as high as 138. Okay, so you see the changes I've made now? Now I'm using more of the tank. So I'm getting as low as to a foot from the bottom and 2 feet from the top. So we've just added a whole lot more tank. And what I expect to see is a lot fewer cycles of on and off. Pump still has to be on for some time, but they don't spend more time turning off. And this is going to be a lot more spread out. There's going to be a lot fewer cycles of filling and draining, assuming it actually can run. It did. And now when it does the update, pump is only on 3 times. So that's 3 starts and stops. It may be on as many hours, but when we're dealing with pumps, those are inductive motors, and so you don't want to start and stop them willy-nilly. You pay a fairly big energy cost to turn on the motor, so you only want to do that once. In this case, it comes on 3 times over a 6 times 12, over a 3-day period, and our tank fills and drains 3 times. So it was the same hydraulic network, same pump, same tank, but by changing the control rules, we get much different behavior in the system.
Like you're changing the height in between that.
Yeah. So that is the simple controls in the EPA net program. So let me go ahead and, I don't think I need to save this, but I want to exit the program and I'll
Can you save in the video?
Yeah.